Hi guys, I am Ron Paulo Antonio and I'm here to discuss to you how to do the assignment problem. So what is an assignment problem? Assignment problem is one of the linear program problems that determines the optimal assignment or allocation of resources. So here we will use the Hungarian method to find the best assignment. Here is an example. The owner of a restaurant estimates the cost of each worker on every jobs. He needs to assign his workers that will minimize the total cost. The cost of the workers are shown in the table. So in this column, here is Jimmy, Kevin, Dexter, and Mark. In this row, these are the jobs: the cashier, server, stocker, and host. And the numbers that you see are the cost of every workers. So step 1. Subtract the smallest number in each row of the original cost table or matrix from every number in that row. Then, subtract the smallest number in each column of the table obtained in part A from every number in that column. So we see in this table 1, we highlighted the smallest number in every row. So the second row, 455, third, 340, the fourth row, 470, and the fifth row, 463. And then after we find the smallest number in every row, we will then subtract it. So 406 on the second row, 469, 590, and 580 subtracted to 455. Third row, 575, 555, 496 subtracted to 340. Fourth row, 572, 569, 574 subtracted to 470. In the last row, 550, 555, and 571 is subtracted to 463. So in this table 2, here are the subtracted numbers. And we also did the part B, where we get the smallest number in each column. So 470 will become the 0. So in this column, that will be the smallest number, 463, 0. The 340 and the 455 will become 0, but we will get the 340. And in here, the subtracted numbers, the smallest number is the 104. So so now that we have the smallest number in every column, we will then subtract it by column. So we have 104, we will subtract it to 125, 156, and 108. Step 2. Check whether an optimal assignment is possible. This is done by finding the minimum number of lines necessary to cross out all the zero cells in the most recent table. If this is equal to the number of people or tasks, then the solution has been found. So in this table 3, we have the lines. So we have the 0, we put the lines. So in this row, we have the 0 and the 0, we put another line. And the last row, we have this 0, so we put another line. If we count all the lines, we have 3, so the solution has not been found yet. Step 3, subtract the smallest number not covered by the line from every other number. Return to step 2 and continue the cycle until an optimal assignment is possible. So the numbers that don't have the lines, we will get the smallest number. So we have the 14, and then subtract it to other numbers, the 235, 135, 215, 21, and 52. Table 5, we have the 0 and the subtracted numbers. The minimum number of lines necessary to cross through all zeros is 4. So an optimal allocation has been found. So the table 5, we have 4 lines. So we found the solution. The next to do after finding the optimal assignment is to assign the workers to do their respective job. To make the final allocation, follow these steps. 1. Find a row or column with only one zero cell. 2. Make the assignment corresponding to that zero cell. 3. Eliminate that row and column from the table. And 4. Continue until all assignments have been found. So we have this table 5. So the first thing to do is assign mark to server job and eliminate that row and column. So this highlighted part, we will eliminate it because we have assigned Mark as the server. Second, we assign Dexter to host job. So we eliminate this row and this column. So 3, we assign Jimmy to cashier job. And the third, we assign Kevin to stalker job. So after that, from the original table, the cost associated with the optimal assignment can be determined. So Jimmy was assigned to cashier, so 469. Kevin Stocker, which has 340. Dexter as host, 674. And Mark as server as 463. So to get the minimum total cost, we add them all. 469 plus 463 plus 340 plus 674 is equals to 1,956.